Okay, welcome to another video where I'm gonna go through IBDP higher level mathematics paper 1, time zone 1. The year is 2017 and I'll be going through questions, and when I go to the question, please stop the video, read the question. Okay guys, read the question, understand the question first before I solve it. Think about the question first before I solve it for 2 minutes at least, for 1 minute at least, and then only watch me solve, okay? You might be based in anywhere, in Hong Kong, China, Singapore, Australia, Canada, Europe, and I hope this video will be useful to you. For those of you who don't know me, my name is Kairat. I'm based in Hong Kong and I tutor mathematics. So, okay, let's get started with this paper. 2017, paper 1, time zone 1. Okay, question 1 is about logarithms. Okay, read the question please. In this paper, by the way, in this video, we'll go through section A. Section B will be solved in the next video to shorten the time. Okay, logarithm questions. Log 2x minus log 2(5) is equal to 2 plus log 2(3). Okay, using the rules of logarithms, the left hand side here will be log base 2 and then x over 5 is equal to 2 plus log base 2 and then 3. So next step, we're going to take this log 2(3) and move it to the left hand side. That means log base 2 and then x over 5 here minus log base 2 and then 3 is equal to 2 on the right hand side. Now, using again the same rule that we have used at the very first step, the left hand side here in the last equation, we're going to divide x over 5 by 3, and that's going to give us x over 15. So that means log 2 x over 15 here is equal to 2. Okay, so we'll have used only one rule so far. Next step. So we will switch this logarithm into the exponential form. Right now we have a logarithm, so we can switch it around and then put the things in appropriate places to get to the exponential form. And what does it mean? So the base here is 2, and this number 2 will go above each other. So that's going to look like this. 2 to the power of 2 here will be equal to x over 15. That's how the logarithms work, right? You get to memorize, you get to be able to switch things around in your mind very quickly, okay? Logarithms and exponential is this one. 2 squared is exponents. So 2 squared is 4 is equal to x over 15, which means that finally x is equal to 60, because 4 times 15 is 60, right? We just take this 15 and multiply with the 4. Okay, question solved. Hope that was clear. Going forward to the question 2. Complex numbers. Pause this video for 1 minute, read it, understand, and then come back. Consider the complex numbers z1, z2, and w is equal to z1 over z2. Alright, by expressing z1 and z2 in modulus argument form, write down the modulus. Okay, let's see what modulus argument form means. Right now, the z1 here and z2 are in the so-called Cartesian form. Cartesian form is when we have a plus bi, right? So it's like 1 plus root 3i. But modulus argument form looks something like this: r, and then there's cis, cis, theta, of an angle theta. Actually, we can swap around between the two using the following formulas. So like to find r, which is modulus, actually r is the modulus. R can be found from a and b, just squaring them both and then adding them and square rooting the whole thing. And then theta, the angle, can be found also from a and b. It's tan inverse. It's arc tan of b over a. So if that's not clear so far, for now, don't worry about it. Let's apply this thingy to z1. So z1, we are given that it's equal to 1 plus root 3i. So what's a here? A is 1, right? So like a is 1 here, and then b is root 3. Alright, so then What's the r for the z1? R is going to be equal to square root of 1 squared plus root 3 squared, which is equal to root 1, and then this is 3, right? Root 3 squared is 3, plus 1 is 4, so root 4 is equal to 2. And how about theta is equal to arc tan of b over a, which is root 3 over 1, right? Root 3 over 1 is equal to arc tan of root 3, arc tan of root 3, and arc tan of root 3 is, as you might, let me recall, arc tan of root 3 is going to be equal to this way, 60 degrees, right? So you might write it as 60 degrees, or you might write it in radian form, like pi over 3 radians, okay? Both of them are acceptable. But in the end, it's better to put it in the radian form, okay? In the radian. So let's do it for z2. z2, we're given that is equal to 1 plus i. 1 plus i. What's the a? A is 1, b is 1. Although we don't have any number here, so it's still going to be 1. It's just going to be 1 then. So what's the r for this? R is equal to square root of 1 squared plus 1 squared, which is equal to root 2. How about theta? Theta is equal to arc tan of 1 over 1, which is arc tan of 1, which is equal to pi over 4, right? Arc tan of 1 is pi over 4. If that's not clear, like how do I find arc tans, just go to the Google and please type the following. So like tangent of this angle is how much? Like for example, tangent of 60, you'll find out that it's root 3. That's why arc tan of root 3 is 60. Okay, and same with like tangent of pi over 4 is gonna give the answer as 1, and that's why arc tan of 1 here is pi over 4. Okay, so therefore for z1 overall, now z1 here we're gonna write it as what was that? R was 2, so 2 cis pi over 3, right? Pi over 3. And how about for z2? z2 here, we know that it's root 2 and then root 2 cis of pi over 4. Okay, so then they're saying write down the modules of w and argument of w. So we need to address the w, but w is z1 over z2. So let's go to that. So w now is equal to z1 over z2, which is 2 cis pi over 3 over root 2 cis pi over 4. And so how much is this? And by the way, 2 divided by root 2 here is just going to be root 2. And then one thing that you guys need to write down is the following. When you have cis over cis, you can actually, cis has the following property. It's just going to be, you would subtract pi over 3 and pi over 4. So pi over 3 minus pi over 4. Okay, minus pi over 4 here. That's the property of cis. That's how the cis works, okay? So therefore now, what we're going to do is, it's going to be root 2 and cis. Pi over 3 minus pi over 4, I'm just going to save time here. You would need to make common denominator here. Multiply this by 4, the top and the bottom, and this, the top and the bottom, by 3. And then subtract them using the common denominators. And then it's going to be pi over 12. Okay, so therefore, the question was, find the modulus of w and argument of w. You'll write modulus of w, as we see, it's root 2, right? Root 2. And argument, simply you can just put arg of w. The angle here is pi over 12, okay? Pi over 12. Next, find the smallest positive integer value of n such that w12 of n is a real number. Can you see? Find the smallest positive integer value of n such that wn is a real number. Okay, let me actually erase this part, okay? Let's make the screen a bit cleaner. I'm just gonna say what we have here for w. So we have found that W is something like this, right? I'm gonna move it somewhere here. Now, we see that W is root 2 cis pi over 12. Actually, on the diagram, this one is gonna look something like this. There's a diagram for complex numbers. This part is called real part, like the horizontal one, and the vertical one is called imaginary part. It's not x and y axis, it's horizontal and vertical, okay? Real and imaginary. So pi over 12 is about 15 degrees, right? 15 degrees. So 15 degrees on this diagram is a very small angle, like this. We always start from this line, okay, from this, and then go in the counterclockwise direction, okay? And so, but that means actually they're asking, oh, find the value of n such that Wn, double to the power of n, is equal to, we know that root 2 is equal to root 2 cis pi over 12, and then all to the power of n, right? This, they're saying, has to be a real number. But in order for a number to be a real number, it has to be like fully on the horizontal axis. So what does it mean? Basically, what I'm saying here is that at the moment, W, which we'll have, is somewhere here. Like this length of this, the length of this line is root 2, okay? That's the modulus. And the angle here, the small angle, is pi over 12. We need to rotate it in such a way that that line, it's on the horizontal axis right now, in the end. So let's simplify this one first. Root 2 to the power of n, right? And then cis. Now, there is the so-called de Moivre theorem. De Moivre's theorem, which states that when we raise cis to the power of any number, that number will go inside the cis. So it's going to look like this. Pi over 12 times n. So pi over 12 times n, okay? That's the de Moivre's theorem. The number n just goes inside the cis. Alright, so with that in mind, by the way, so let me mention the following, that basically, if we manage to get this line onto the horizontal axis somewhere here, then it's going to be a real number, right? Because it's fully on the horizontal axis. It doesn't have any imaginary. It doesn't go up, it doesn't go down, like it's doing at the very beginning. So how many times do we need to bring it here? So actually every time it goes by 15 degrees, 15 degrees, 15 degrees, 15 degrees, and so on, 15 and so on, right? Because this one is 15 at the very beginning. But actually, this yellow angle is pi, right? Because that's 180. 180 degrees is pi. So essentially, n can be 12, because pi over 12 times 12 is pi. But of course, we can choose n to be 24. Like if we choose n to be 24, what's going to happen is pi over 12 here times 24 will be 2 pi. Then that goes all the way back to this line, which is also going to give a real number, but that's not the smallest. The question here is find the smallest positive integer, right? Find the smallest positive integer, which means that we should choose a smaller value. So hence n is equal to 12. Now when n is equal to 12, what's the answer to this question? W to the power of 12 is going to be root 2 to the power of 12, right? Root 2 to the power of 12 times cis. Pi over 12 times 12 is just pi. And it's going to be a real number. By the way, cis of pi, you will just, you can just Google it somewhere, or if it's not clear, just comment in the comments below, like how did I find this? Cis of pi is just -1. So this is a perfectly real number, right? Real number. There is no imaginary number, so this is a perfectly real number. Okay. And let me mention one last thing here, one more thing about CIS. All in all, CIS is actually the following. Write it down, please, somewhere in the notes, guys. CIS is equal to, CIS of any angle is equal to cosine theta plus I sine theta. Okay, so therefore CIS of pi, for example, we can find it out easily by cosine of pi, not cosine theta, cosine of pi plus I sine of pi, okay? Cosine of pi here is -1 plus I sine of pi is 0. So that's equal to -1. Okay, that's how one. Okay, hope that was clear. Let's continue. Solve the equation. Secant squared plus 2 is tan theta is equal to 0, where x is between 0 and 2 pi. Okay, so first of all, when you see secant and tangent in the same equation, always think about the following formula. Tangent squared x plus 1 is equal to secant squared x. This is a very, very useful formula in trigonometry. Same as all of you guys know this, right? Sine squared x plus cosine squared x is equal to 1. This is very, very well known. This is also, I would say, this is the second most important formula in trigonometry after this one. Okay, so why am I mentioning this is because now basically what's going to happen is this secant squared x will be replaced with tangent squared x plus 1, okay? Because that's secant squared x. Alright, so then that equation, the whole equation now turns into tangent squared x plus 1, right? Instead of secant squared x plus 2 tan x. Plus 2 tan x is equal to 0. So let's rearrange things a bit. Tangent squared x plus 2 tan x plus 1, right? Plus 1 here is equal to 0. And then we can actually, this looks like a quadratic equation, right, guys? That's gonna give us the following. Tan x plus 1, we can factorize into 2 brackets. And tan x plus 1 is equal to 0. And from here, using the null factor law, or you might call it in some other ways, this could be 0, right? Or this could be 0. But actually we see that they're both the same. So it will have only one case. Tan x plus 1 is equal to 0, which means tangent of x is equal to -1. Alright? Tangent of x is -1. Now we solve this equation that we'll have. Tangent of x is equal to -1. What's the value of x, right? So it's going to be arc tan of -1. And that's equal to, arctan of -1 is equal to 3 pi over 4. 3 pi over 4. Okay? And one thing about tangent is when you find the first solution, like we'll have here, 3 pi over 4 is the first solution. What you're going to do, guys, is there's also the second solution, okay? Because the question was like x is between 0 and 2 pi. Usually, when the domain here is between 0 and 2 pi, there are usually 2 solutions, or maybe more, right? But usually there are 2 solutions. This is the first solution, 3 pi over 4. The other solution for tangent, please memorize it, guys. For tangent, you just add pi to the first solution. So that's going to be 3 pi over 4 plus pi, all right? Plus pi. So which is equal to, when you add these two together, pi is 4 pi over 4, add it to this, it's going to be 7 pi over 4. Okay, so we'll have 2 solutions, 3 pi over 4 and 7 pi over 4 in this question. And both of these numbers that we'll have are within between 0 and 2 pi. Okay, so that was 5 marks. Let's go to the next one. Combinatorics question, probability question. 3 girls and 4 boys are seated randomly on a straight bench. Find the probability that the girls sit together and the boys sit together. Okay, so we're gonna put 7 spaces here. We could have the girls here and the boys there, right? Girls and boys. Or we could also have the following scenario. When we have girls here, right? So, I mean boys here, the 4 boys here, and then the girls here. Okay, so let's consider the first case. Okay, 3 girls. In how many ways can 3 girls even if they sit on the first, second, and third seats, in how many ways can they interchange within the among each other? So Annie, Natalie, and Michelle, or Annie, Michelle, and Natalie, or Michelle, Annie, and Natalie, or Natalie, Annie, Michelle, like this, right? So in how many ways they can change? Since we have 3 girls, it's simply gonna be 3 factorial, okay? So that's the approach. Basically, it doesn't matter if they're girls or boys. What about for boys, for example? 4 boys. Michael, Anton, Kairat, and then Rick. So in how many ways can this swap among each other, right? So it's 4 factorial ways. 4 factorial ways, okay? So we multiply this. And by the way, the sign in between is multiplication. It's just simply the rule, the way it works, okay? So 3 factorial is 6 times 4 factorial is, what is that? 24, right? So multiply that is 144. What about this? 4 boys swap among each other, switch among each other is 4 factorial times girls is 3 factorial is equal to 24 times 6, which is equal to 144. Okay, so if we add these 2 numbers, it's going to be total of 288 arrangements, right, of the teenagers, such that the girls sit together and the boys sit together. But the question is, find the probability, right, that the girls sit together and the boys sit together. So we're going to divide this number 288 by the total number of possible arrangements. So it doesn't matter, Annie, Michelle, and then Michael, and then Jordan, and then Rachel nearby. So in how many ways can we sit the 7 teenagers on the bench? 7 teenagers is just simply gonna be 7 factorial, okay? When we don't have any constraints, 7 kids or 7 people can be seated in 7 factorial ways. All right, so then let's calculate this. 7 factorial is 7 times 6 times 4 times 3 times 5 here somewhere in the middle, times 2 times 1. Okay, and then once you simplify this, let me just do it very quickly here. So I think we can simplify this 24, so cancel this 4 by 24, it's going to be 12, and then we'll have 7, 6, and 5. And then it's 12 and 6 cancel, so there is 2 here. So the answer is 2 over 35. I hope that's right. Yeah, I'm pretty sure that's right. But do please check this number on your own, guys, and then let me know in the comments if that was correct. I'm pretty sure it's correct, unless I'm being a bit not smart in the calculation. But the approach is like this, okay? Approach is like this. We find the number of ways and then divide by total, which is 7 factorial in this case. Okay, so question 5 here is vectors question. ABCD is a parallelogram. Let's just quickly draw a parallelogram like this, right? Like usually it looks like this, parallelogram. And so A, B, C, D. All right, and then let's connect the points, let's connect the dots. And then AB is equal to this, AD is equal to this, and then they say find the area of parallelogram ABCD. Now guys, there is a concept that's called cross multiplication, right? Cross multiplication of vectors, multiplication. So how does it work? Basically, let's say we have a vector x, okay, vector x, and you want to multiply this with vector y, cross multiplication. So you're gonna put the cross in between them, and then that's gonna be equal to magnitude, the length of vector x, okay? These two kind of like absolute value. It's actually not absolute value. This means it's the magnitude, okay, times the magnitude of vector b, and then times the sine of the angle sine theta. Now theta here is the angle between x and y. So imagine theta is like x, the vector x is like this, vector y is going this way, and so the theta is the angle in between, okay? So, and then also we need to put the magnitude on the left hand side, because all we're saying here is that x cross y, the magnitude of that is equal to magnitude of x times magnitude of y times the sine of theta angle between them. Now, why am I saying this? Is because you remember, guys, like in trigonometry, you have studied the area of triangle formula, which looks like this: 1 over 2 AB sine theta, right? The angle, the area of triangle looks like this. For AB are the two sides. Now, this one actually looks very similar to the area of triangle formula, right? So what if we simply put 1 over 2 here on the right hand side and 1 over 2 on the left hand side? That means this is kind of like an area. So how is it useful? What if we look on this AB, right? The vector AB, and then we also look on the vector AD here. And what if we do cross multiplication in between them? We will be able to find the area of this triangle, right? So AB, vector AB, cross with a vector AD, magnitude of this, and then 1 over 2 is actually equal to the area of this triangle here, ABD. Okay. Now 1 over 2 here is because we'll have 1 over 2, right? And 1 over 2, this thing that we'll have is actually the formula for the area. But we want to find the area of parallelogram, right? And one thing that we know is that the ABD, the triangle ABD, is exactly identical to BCD. They are equal to each other. So we can essentially multiply this answer that we get by 2. So in that case, this 1 over 2 will be gone. So times by 2, right? 2 times 1 over 2 is just cancels out. So that's going to be magnitude of AB cross with the AD. So guys, remember this thing, please. If you want to find the area of triangle, you can just use the cross multiplication. AB cross with the AD, okay? But then you need to put 1 over 2. But then if it's a like this parallelogram, then you just multiply by 2 because there are 2 of these triangles. And that's going to give AB cross AD. Now the question is, it's not to, we're not done yet because we actually need to find the number, right? And we therefore we need to do cross multiplication here. We need to do cross multiplication. So copy this down, please, on the paper, guys. Understand this, pause this video, watch this again because I have mentioned a couple of not very easy concepts, and it was about the area, right? And then I'm gonna show how to do cross multiplication now. How to do cross multiplication. Okay, so now we need to do AB cross AD, right? We need to find out what that is. To do that, we need to put AB in this way. So minus I plus 2j plus 3k. What are the numbers there? Minus 1, 2, and 3, right? 2 and 3. And so actually we can just put this AB in this way, like minus 1, 2, and 3. A lot of times you will see vectors written in this way, and then cross with the AD, which is 4, minus 1, and minus 2. 4, minus 1, and minus 2, right? And so it's gonna give us, what we're gonna do is, to find the first row, we will have 3 rows here, 1 row, 2nd row, and 3rd row. To find the first row, what we need to do is we multiply 2 by negative 2 first, so 2 times the negative 2, and then we minus 3 times negative 1, okay? 3 and negative 1 here. So 2 times negative 2, 2 times negative 2 minus 3 times negative 1. And so we're going to calculate later on. So how about for the second row? For the second row, what we need to do is we need to forget about the second row on the left here, and then just focus on the numbers 3, 4, and then minus 1 and minus 2. But we are going to start with 3, okay? Because we always start with the number that goes after the second one. So 3 times the 4 minus negative 1 times negative 2. Right? And then the last row here, we go back to minus 1. We forget about this line, so minus 1 here times the minus 1 and minus 2 times 4. So that's the way we find, and then we need to just calculate what this is. So 2 times negative 2 is negative 4 minus So we'll have negative sign here and negative sign, so it's going to be +3. So -4 + 3 is -1. 3 times 4 is 12, and then we'll have minus, minus, minus 3 negative signs, so it's going to be negative. So 12 minus 2 is 10, and then -1 times -1 here is 1, and then we'll have -8. So 1 minus 8 is -7. And so, therefore now, AB cross AD, the magnitude is equal to the square root of these numbers that we got, -1 squared plus 10 squared plus -7 squared, and then that's equal to square root of 150. Okay, so that's the answer to part A, okay, root of 150, using the cross product rule. Okay, part B, by using a suitable scalar product of two vectors. Now they're saying scalar product. Well, I will explain what that means, okay? Scalar product. Determine the angle, whether angle ABC is acute or obtuse. So angle ABC, where is the angle ABC? Angle ABC is this one, right? But we don't know the value of that angle. Even if on the diagram it looks like obtuse, we don't use the diagram because this diagram is just my drawing, right? It's just hypothetical drawing. We don't exactly know how it looks like. So ABC, right? We need to find the value of angle ABC. Okay, let's do it. I'm gonna erase this. Hold on, so before erasing actually, maybe we can use some... Okay, root 50, right, was the answer, root 150. Now, part B. Let's just draw the diagram like this, right? So let's say the parallelogram looks like this, A, B, and then C and D. So we know that AB is equal to, what is that? -1, 2, and 3, right? -1, 2, and 3. What was AD? AD is 4 minus 1 minus 2. 4 minus 1 and minus 2. And so, scalar product is the same as dot product. Dot product. Now, dot product is a bit different from the cross product. Previously in part A, we have used cross product, right? So that's a bit different from dot product. But we need to find the angle ABC, right? This angle. Okay, we know AD, we know AB, we know AD. Actually, when we go from point A to point D, from this diagram, we know that vector AD is equal to vector BC, because both of them actually go in the same direction, right? In this way, and then they have equal length, because this is parallelogram. BC itself is equal to AD, and then they go in the same direction. For vectors, the order is very important. So B goes first and then C, from B to C, right? That means AD means from A to D, in this direction, right? Okay. Which means that actually BC is the same as AD, which is 4 minus 2, 1 and minus 2. 4 minus 1 and minus 2 here. Alright. So we can actually find the angle between AB and BC now. But to find this angle, let's just call it theta. What we need to do is we need to focus on the vector BA and vector BC. So once here's why, basically. Because if you want to find the value of the angle in between two vectors, you got to focus on the two vectors that originate, go away, right, from that point. So this vector here is actually BA, the vector BA, and this vector that goes from B is vector BC. Okay, so what's BA? Let's find out the BA. Turns out it's very easy, because BA is just in the opposite direction as AB. That means that BA, vector BA, is going to be equal to the negative of AB, which is 1, -2, and -3. okay? 1, -2, and -3. And so now let's do dot product. So BA dot, you will just put a fat dot like this, dot BC is equal to, by essentially BA, which is 1, -2, and -3, dot with the BC, which is 4, -1, and -2. Okay? So now we need to do the multiplication. Actually, this multiplication, the dot multiplication, is quite different from the cross multiplication done in part A. It's not very complicated. This one is quite easy actually, because we'll simply multiply the numbers on the same row. So 1 times 4 in this case, 1 times 4, and then plus the -2 times -1, so -2 times -1, okay, and then plus the last row, -3 times -2, so -3 times -2, okay? We just do this. Quite easy, because we don't need to do all like this, and minus them, and then this, and minus, like we've done in part A, okay? So let's find out the value of this. So 4, and then we'll have plus 2 here, and then we'll have plus 6. And so this is equal to 12. But that's the dot product. It doesn't give the answer yet. This question is a bit long actually. So now BA dot the BC, another way to find this is to use the following. It's equal to the length of BA, so magnitude of BA, times the BC, magnitude of BC, times actually the cosine of angle between them, so cosine of this angle that we have, right, cosine theta. So let me just separate this. Now we know already that actually BA dot BC, we have found that it's equal to 12, right? So we will put 12 on the left hand side. But what's the magnitude of BA? It's quite easy to find using the formula where BA is going to be 1 squared, right, plus -2 squared, -2 squared plus -3 squared, and times, how about the BC? BC is going to be, where's the BC? BC is here. So it's going to be 4 squared plus -1 squared plus -2 squared, and times the cosine theta in bit after that, right? Cosine theta after that. So okay. So 12 therefore is equal to root. This is going to be 14 times root. This is going to be 16 plus 1 plus 21. Okay, times cosine theta. And so that means cosine theta is equal to 12 over these two. So root 14 times root 21, right? Okay, so that's the value of cosine theta. And finally, we can find what theta is, cosine inverse of that whole thing, right? So 12 here, and then over root 14 and root 21. And using calculator, I'm quite sure it's gonna give an acute angle. So this is acute, okay? Please use the calculator to find out the actual value of cosine inverse of 12 over this root 14 and root 21. Okay, so in this question we have used cross product and dot product. Please rewatch this segment again to understand it in more detail. Okay, guys? Thank you for keeping up so far. It's not been easy, but I think this one will be very easy actually, this question. So consider the graphs of y is equal to the absolute value of x, y is equal to negative absolute value of x plus b, where b is element of z plus. Now b element of z, this means element of, and z plus means positive integer, right? So positive integers are like 1, 2, 3, 4, 5, 6, 7, and so on are the positive integers. Okay, sketch the graph on the same set of axes. So it's very simple because the first one simply looks like this. This is the graph of y is equal to absolute value of x, okay? And what about the other one? Minus absolute value of x plus b. Now, first of all, negative absolute value of x is flipped down like this, right? Negative absolute value of x. This is just negative absolute value of x. But if we do plus b, this graph will be just moved up. So let's say it just goes up to this point, right? So the graph is gonna go like this, okay? In the same direction, but just should be straight, actually, more straight. So I'm gonna erase this part here, this one. I should just erase it. And so this is actually point B, okay? This is 0. And so that's it, that's the answer. But you guys need to make sure that it actually goes in between. So the angle is 45, 45, okay? So it just goes directly. Doesn't go down, doesn't go, yeah, just use the ruler, guys. Okay, part B is saying, given that the graphs enclose a region of 18 square units, find the value of B. So that means this area is 18, right? But this is actually a square. This is a square because all of them are very straight, so yeah, it's a square. Now think about this, guys. Like, let's just draw it here, that square out. As we have seen, actually, this part of the graph is B, right? Exactly B. That's one of the diagonals. Now, another diagonal is also equal because the square has equal diagonals. And we also know in a square, the angle in between is 90. This diagonal is root B, B, and this angle is just B. But how to find the area of this? Of course, we can multiply side times side, but we can also multiply the diagonal times diagonal, which is B times B, and then we have to divide this by 2. Memorize, guys, like for the square, diagonal times diagonal, divide by 2 is the area. Now, why is that? It's because what you can do is actually complete this into another square like this. Now, this full square, this square that's on outside of the square inside, is twice as big, right? Because this is equal to this, 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 right? And the side length, this one is B, and then this one is B, and the square area is B times B, right? So that's why we need to divide by 2 to have an area of the square that we have. So it's equal to, they're saying is 18. And so that means B times B is equal to 18 times 2, which is 36, which means that B is equal to 6. Okay, guys? That's it for this. Let's continue. All right, so question 7. An arithmetic sequence U1, U2, U3 has U1 is equal to 1, common difference D not equal to 0. Given that U1, U2, U2, U3, U6 are the first 3 terms of geometric sequence, find the value of D. Okay, so we have U1, they're saying it's 1. What's the U2 then? U2 is, we know that actually to go from U1 to U2, we just add D, so it's 1 plus D, okay? What about U3? To go from U2 to U3, just plus D, right? Plus D. But we know that this is already 1 plus D, so it's going to be 1 plus D, which is 1 plus 2D. What about U4? It's equal to 1 plus D again, so plus 3D, right? What about U5? It's equal to 1 plus 4D. What about U6? Is equal to 1 plus 5D. Now, you don't need to write out everything here. You can just use the formula for the arithmetic sequences. But why am I writing this is because we know that given that they're saying U2, U3, U6 are the first 3 terms of geometric sequence. So let's focus on U2, on U3, and U6. So 1 plus D, right? 1 plus 2D, and then 1 plus 5D are the first 3 terms. So first term, second term, and third term in a geometric sequence. Now, what do we know about geometric sequence is that, I'll give you an example, guys. So let's say we have 5, 15, and 45. This is geometric sequence because every time it's times 3, right? Times 3 and times 3 here. Now what we know else is that if we divide this 15 by the previous term, which is 15 over 5, it's just going to be 3, right? This number that we have. And that's equal to dividing 45 by 15, 45 over 15, which is also 3. So why am I giving this is because now if we divide 1 plus 2d here by 1 plus d, that's equal to dividing 1 plus 5d over 1 plus 2d, okay? Let's do it. So simply, it's going to be 1 plus 2d over 1 plus d is equal to 1 plus 5d over 1 plus 2d. Next, we're going to cross multiply. Okay, cross multiply. So 1 plus 2d times 1 plus 2d is equal to 1 plus d, 1 plus 5d. Okay, let's expand this. 1 plus 1 times 2d, 2d here, plus 2 times 2d here, plus 2d times 2d is 4d squared, is equal to 1 times 1 is 1, plus 5d here, plus d times 1 is d, plus d times 5d is 5d squared, okay? And then let's simplify this. 1 plus 4d plus 4d squared is equal to 1 plus 6d plus 5d squared. And so let's bring everything to one side, so that let's just bring this whole thing to the right hand side. So that means the left hand side will be 0. So now 0 is equal to 1 and 1 will cancel out. Now 6d minus 4d is 2d, and then 5d squared minus 4d squared is plus d squared. And then we will take d outside the bracket, so d and then brackets d plus 2, right? Because d times d is d squared, d times 2 is 2d. So this is equal to 0. From here we'll have two cases. So either this is 0 or this is 0. So d is equal to 0 or d plus 2 is equal to 0. Okay, so d is 0 or d is negative 2. But we know that at the very beginning we were told that d is not equal to 0, right? They're saying d is not equal to 0 here. So therefore, this case is rejected. Okay, so d is equal to negative 2 is the answer. That's the answer to part A. Now let's go to part B. Keep in mind, d is negative 2. I'm erasing this. So d is negative 2. They're saying un is equal to negative 15. un is equal to negative 15. And determine the value of, this is summation notation, okay? Sigma. You call it sigma or summation notation. Sum. You can just call it sum. So what this means is, when you see something like this, like r is equal to 1 and up to n, ur, simply means the following. We start from 1, so u1 here plus u2 plus u3 plus ... The last term will be when r is equal to capital N, so u and then n here. So the sum of the first n terms. The sum of the first n terms, okay? So, but for this one, there's a formula which goes like this: S capital N, which means sum of the first n terms. In arithmetic sequence, it's n over 2, 2u1 plus n minus 1 times d. But do we know what this n is? By the way, this capital N should be just capital N, the same thing, right? The same thing as capital N. But we're told that un is equal to minus 15. We don't know what this capital N is. Which term is it? Is it the 5th term? Is it the 6th term? Is it the 7th term? We're going to use this formula, which is un is equal to u1 plus n minus 1 times d. Now, instead of un, we're going to put, keep in mind, this capital N and small n is just the same, negative 15, right? It's negative 15 here. u1 is 1, right? It's given here at the very beginning. u1 is 1 plus n minus 1 times, now d we have found, d is negative 2, so we'll put negative 2 here. Then from this equation, we can just solve for the value of n, right? Find out the value of n. Okay, negative 15 is equal to 1 minus 2n. Minus 1 times minus 2 is plus 2. and so negative 15 is equal to 3 minus 2n, and then from here we'll just find out that n is equal to 9, okay, n is equal to 9. So that means now we just need to simply find out the sum of the first 9 terms, because we have found that n is equal to 9, so this just changes to 9. So using this formula now we need to find S9, okay? Keep in mind, guys, in arithmetic sequence there are only two formulas. One is here, okay, which goes like un, the nth term is equal to u1, which is the first term, plus n minus 1 times d. The other one is the summation, which is Sn is equal to this, okay? So S9 now is equal to 9 over 2, just put 9 here, and then 2u1, we are given u1 at the very beginning is 1, plus n minus 1, which is 9 minus 1, which is 8, times d, and we have found d is negative 2. Okay, we just need to solve this. Is equal to 9 over 2, 2, and then minus 16. And so this is equal to 2 minus 16 minus 14, and then 9 over 2 times minus 14 is going to be equal to negative 63. Okay, that's the answer to part B. Alright, so we are almost there. We just have a couple questions left. I think this paper is getting quite long, right? This video is getting pretty long. So what I'm going to do, let me just do this very quickly and then call it here, okay guys? I think you guys might be tired watching this video already, and me too, probably, as you can see from my voice, but that's okay, everything is fine. Use the method of math induction to prove that this number is divisible by 9. So math induction, we start with this. Check for n is equal to 1. Check the, well, checking what? Check the statement, right? So we just put n equal to 1 here. So 4 to the power 1 plus 15 to the power 1 minus 1 is equal to 18. And is divisible by 9, right? Okay, so it works. This statement that they're saying works for n equal to 1. And then, next step, that's the first step. Second step is assume the statement in the question that they're saying. The statement is correct for some number, for n is equal to k, where like k is larger than or equal to 1, okay? Some number like 10, 12, 15, 100,000. And then we will just use that k, the number k, and extend by 1 to k plus 1 to the next one. And using this, actually, if we assume for k, prove it for k plus 1, we can prove it for k plus 2, for k plus 3, for k plus 4. The main thing here is that we are just naming it k. We're not choosing specifically 12 or 13 or 14 or 15 or 16 or 25. We're just choosing k. That's a very big difference. When you choose k, that means it can be any number. Prove it for any number. Extend it by 1. You can do it for any number. So for 1 million. That's the beauty of math induction. It's not specific case. It's just k, some random number, which we don't specify, okay? So it's true for n equal to k. That means 4 to the power of k plus 15k minus 1 is divisible by 9, which means it's equal to 9 times a, right? And then you'll need to write for some a element of integers, okay? A is some integer. A is element of z. So then you write then, let's do this. 4 to the power of k is equal to 9a. Bring this 15k to the other side, 15k plus 1, and 1 also to the other side, okay? Now why do we do this is because, now let's extend it to k plus 1. So 4 to the power of k plus 1 what's this? Is equal to times by 4, right? The left hand side and right hand side by 4. So 4 and then 9a minus 15k plus 1. And then expand this, it's 36a minus 60k plus 4. And now going back to what we had here, 4 to the power of blah blah blah. So let's find out what this is. 4 to the power of k plus 1 plus 15 to the power times k plus 1 minus 1. How much is this? Now we have found out that the value of 4 to the power of k plus 1 is here, right? At the bottom we have written that. So let's just put that in. 36a minus 60k, right? And then plus 4. And right, that is just the 4k plus 1, which we'll have here. All we have done right now is just instead this 4k plus 1, have put what we'll have here, and then plus, we expand this bracket, so plus 15k plus 15 minus 1. Let's simplify this. So 36a, and then minus 60k plus 15k is minus 45k, and then 4 plus 15 minus 1 is plus 18. So it's equal to, we see that 36, 45, and 18 divisible by 9, so we take 9 out, and so it's 4a minus 5k plus 2. Okay? And therefore, this number that we'll have is divisible by 9. Okay? So it's divisible by 9. And that means actually we have proved the statement for k plus 1, because as you can see here we have k plus 1, right? And that's exactly like looks like the original one, which we'll have made it on purpose. So and then you'll say, oh, hence at the end, hence the statement is correct for k plus 1. And then you'll say, by principle of math induction, we have proved for by principle of math induction, this expression is divisible by 9 for all n element of z plus, okay, integers. All right. Last question, and then I think after that is section B already. Section B not in this video. So integration. This one looks very simple. Find integral of arc sine x. Okay. But just by looking at it, one thing that comes to my mind is by parts, integration by parts. Nothing else. Integration by parts. So what was it? Integration by parts. It was like this. Integral u dv is equal to u times v minus v du. You might ask, what's u? What's v? Chirat. What's u? What's v? Chirat. Explain me. Explain to me. What's that? So here's what's that. Now, u is some function and v is some function. Now, how can I apply that in this case? Now, think about it this way. How about arc sine x? Here is u. And then dx is just dv. Okay? So, to this expression, we can do this. U is equal to arc sine x. Okay? Just what we have there at the beginning. And then v here is, dv. Right? dv is dx. But then, dx. But then that means v is equal to x, right? v is equal to x. Now, when you do by parts, please always highlight, put it inside the boxes. U inside the box and then v inside the box, okay? Put them in boxes. That's a very good practice. You will see why. So then, this one, using the formula, using this formula, u times dv is equal to u times v. So we multiply u with v, right? These two, arc sine x times x. So x times arc sine x minus integral of v, what do we put? X, right? And then d of u, which is arc sine x, d of arc sine x. And so then we simplify this a bit, x arc sine x minus integral of x. Now, derivative of d arc sine x simply means derivative of arc sine x, okay? And you can just go to the Google and then type this in. What's the derivative of arc sine x? You'll find out that it's equal to 1 over square root of 1 minus x squared, okay, and dx. By the way, when you do this, d arc sine x, we always have dx at the end, okay? That's just the way the derivatives work. We always need to put the dx at the end. And also, by the way, for integrals, we always have the dx at the very end attached to it. That's just a format, okay, to write it. Okay, so let's find this integral. So, and then that's equal to x arc sine x minus, let's just put this nicely like this, x over square root of 1 minus x squared dx. Now this one, the last integral can be done using the u substitution. Okay, u substitution. So how it's gonna work? Basically, let's just focus on this part for the time being, for a second. You would say let u be equal to, usually what's inside the square root here, 1 minus x squared in this case, right? 1 minus x squared. And then you'll find the du right after this, okay? Use that. That means du, derivative of 1 is 0, minus x squared is minus 2x, and then dx at the very end. Okay, and so therefore the dx here, let's make the dx the subject. So separate it, leave it on itself, so du is over minus 2x, okay? So dx is equal to du over negative 2x. So now putting all of that into this integral. Instead of x, we just put x there, and then it's going to be a root. 1 minus x squared is u, right? And then instead of dx here, we'll put what we'll have here, du over negative 2x. Okay? And then let's simplify this. As you can see here, the x and x cancel out. Alright, so then that's integral of du over root u. Du over root u. But then du over root u can be written in this way. By the way, this arc sign we just copy down here, right? This arc sign, don't forget about it. It's still on the left, on the, where it is, okay? So this root u is u to the power of negative 1 over 2. Now, if you're not sure about this, yeah, I hope you're sure, guys, about this. Like, why is, like, when root, just remember this, when you have root u at the bottom, it's just u to the power of negative 1 over 2, okay, and then du nearby. And so, what's the integral of this? We raise the power by 1, right? We increase this by 1. So the integral of that is u to the power of negative 1 over 2 plus 1 divided by the same thing, negative 1 over 2 plus 1, okay? And so what's that? Negative 1 over 2 plus 1? It's u to the power of 1 over 2, and then negative 1 over 2 plus 1 here is also 1 over 2. And so let's put it this way, u 2 root u, right? U to the power of 1 over 2 is just root u. So that's equal to 2 root. Instead of u, we'll just put back what we'll have here, right? At the very beginning, you remember, guys, we have made like u be equal to 1 minus x squared. So that means just we put it back here. And then we will need to put this in the answer, right? So all in all, x arc sine x, x arc sine x. Then we'll have minus sign, right? Minus this 2 square root of 1 minus x squared. And then also we need to add plus c at the very end, okay? So for the integrals, always please, guys, make a habit to put plus c at the very end, okay? Plus c at the very, very end. All right, so that was the solution to this question. We have used the by parts as well as the substitution, okay, u substitution. I hope this was useful to you guys. Please let me know your thoughts below in the comments section if you found it useful, if you have any questions, if I've done a good job. If I've done a good job, please give me a thumbs up. It will help a lot to my channel for it to grow. Subscribe to the channel. And also, if you have friends who may benefit from this video, send this video to them for them to watch. I hope you guys will do well in your May exams that are coming up very soon in 3 months in May, right? And then you will do well in IBDP. For some of you guys, it's coming up in November. And for some of you guys, you are not having any exams soon. And you are lucky, right? So, wherever you are, thank you for watching. And I will see you all, guys, in the next video. Thank you. Bye-bye.